Hello and welcome to yet another video. Today we have a board sent in by a viewer. So we have here I have an MSI B450 Tomahawk Max motherboard that has gone crazy and then died. At first it was complaining of a CPU issue on the debug LEDs and not showing a picture out. Then I switched RAM over to another slot and it booted to BIOS. Upon restarting it then complained about RAM on the debug, so I also switched that around another slot and it would once again go into BIOS, but on another reset again it would complain about RAM, and switching to another slot yet again got it to boot into the BIOS. However, now the board shows absolutely no sign of life at all when trying to power it up. The CPU I was testing in this board was a Ryzen 5 1400. Hope you can do your magic to this board and save it from becoming e-waste. Thank you and kind regards from Shane. This board is out of the UK, and yeah, he sent me the board out. I didn't know what was wrong with it, and it seems to be an intermittent boot issue at first and now not booting at all, and it seems to be something related to the RAM. And yeah, so there has been a lot of so I think there's been a lot of times where something has been taken off and on of this board because he was troubleshooting it already. So there might be a knocked off component somewhere. I don't think there will be short circuit or something like that. But let's see how this board will behave. So let's instantly connect it up and see for its passive power consumption. So its passive power consumption, 65. That's really low. That's really, really low. Like, as low that some of the standby voltages might not be running with like 40 milliamps. Let's see as soon as we plug a CPU into here if anything will change. So now we have a CPU in here. This is 2200G, and we have a little bit more. Let's get a DDR postcard into here, and let's populate one slot with RAM. We now have a power button and also a speaker. There's no CMOS battery because they are not allowed to send out boards with the CMOS battery attached in them. So let's try this. And we do have a reaction to the power button, and we do have a CPU LED stuck on CPU. We have 2.3 amps and nothing. No beep codes, nothing, but the CPU is getting warm, so that seems to be working. Okay, let's get a newer processor into here. Let's get a 4100 into here and see if it also reacts to that. Okay, it doesn't recognize the CPU. We have an instant beep, so let's put the 3000G in here, see if it reacts differently. So the 3000G also seems to try to post. CPU's very getting warm, just like you would expect it. The amperage is quite high, but we're still stuck on a CPU LED, so there's no change in that at all. Let me have a look around this board, because this board has been taken probably out and put in multiple times and has been worked on, like not in a soldering wise, but like someone trying to troubleshoot it. I will inspect the board under the microscope and I will see if there's any damage to the board. So first thing I do is go around the CPU socket to see if there's any damage close to it or close to the mounting holes. And if I found anything, I will get you back into here. So I've checked the area around the CPU and also around the PWM controller, and I wasn't able to find any problems with that. So the main area that I go to afterwards is the area close to the BIOS chip, so above the PCIe slot in this case. And there seems to be no damage. And then the next one is this one, the area that is close to the CPU socket but is beneath it. And if I can't find any damage like here, I would then continue on to the PCIe slots to see if anything has happened there. And if the PCIe slots don't have any damage, okay, this MOSFET looks like this either has been soldered. Has this been soldered before? I don't think so. But it's weird how this one looks. Interesting. There's just some debris. But nothing damaged so far. So let's go around the DDR slots, because there's been a lot of plugging in and out of these slots, and there's a resistor right there in the middle that kind of looks like it got a hit or something, but I think it should be fine. But let's keep that in mind. Okay, this definitely looks like it either has been like water damaged or it has been soldered too. But it more looks like there's been liquid on here. But I gotta say, the power consumption looked very healthy for the board. Like, I don't think that there's anything like that. The diode there in the middle looks so weird. Like someone maybe put in the something wrong with the RGB into here. But no damage there. Let's go to the SIO and look around that area. And now we get close to the SIO. Oh, yeah. There is quite some damage. Okay, let's get this into a better shot. So I can even see exposed copper, not only pads that look like there's been quite something ripped off, but also exposed copper lines. So it looks like that transistor down there got damaged, or whatever it is. And all of this area right here has been damaged. And I really can't tell where there should be a component here and where there shouldn't be. Probably first thing I would do, because I know now how this area looks, I would clean off these contacts. Or do we instantly just go into board view and look this up? Let's go into board view and look what kind of components are missing here. If there's even any missing here, but I'm pretty sure that there's got to be at least one component missing here. Like, there's so much damage right there. So now in our board view software, let's go to the SIO and let's see in this area. So this is not populated. Okay. This is populated and this is still on the board, and this is populated. This is a 1K ohm resistor. So this is already missing. And RTSA. This has to do something with the multiplexer that is there. This is probably important, pretty sure. This is not populated. Let's see. This is not populated. This is not populated. This is also not populated. This is not populated. This is also not populated. This is not populated. And this one is also not populated. So the first three, and the fourth one is populated, and this one is actually there. Okay, and the fifth one is also not populated, and the rest of them look good. So there's a single 1K ohm resistor missing only here, as far as it seems. So there's one resistor in this bottom left here missing. So that's way less than I expected there to be. But that might also already be our culprit. So let's put a 1K ohm resistor into here and see if that solves our problem. So what I like to do first on boards that have this much damage, where pads are in this state, is that I like to take some flux and just put solder on all of these pads and clean this area up. So I will flux it up like this. Then we take leaded solder. You could use any solder you want, but in my case I use leaded solder. And then we just will go over these pads and clean them up, that we get a better view of what is happening here. Because there might even be damaged traces, like you can see here, and we want to get that exposed. This doesn't seem to be any something. The big question is also about this transistor. I didn't really look up what this transistor is for. We will have a look at that as well, if that is important or not. But first we will put in the 1K resistor and see if that has any change to the board. So you can see I used quite some of these already. Now drop down. And what I like to do very often is I grab the component. This is 0402 if you're wondering. I tack on one side like this. And then I just reflow it into place. The one tag side is that it is in place and that it won't go anywhere. and then the reflow is for actually making contact, proper contact. And now I think we have good contact. When we can move it and it moves back like that. Let's see, let's reflow this one as well, because this is close to the area that got damaged. And this one is also reflowed. And let's now clean up the area and see for the tracks, if any of the tracks is actually damaged to a point where we have to rebuild something. So let's first get a lot of IPA and a cotton bud, and I will be cleaning up the area now while it's hot, because the cleaning up then makes it way easier to get the flux off. So the board is now cleaned up mostly. Let's now get a closer look and on that area where we have the broken traces, or to verify if those are even broken or not. And let's see now. So the resistor seems to be nicely in place. The damaged trace is this one, I think, that leads here, but there's no component, so I don't think that this is important. This has been reflowed. This is the one that we put in. There's nothing here as far as I can tell. And this trace goes here, and then it's kind of hard to see. This one goes to this here, and this one also leads down here. But I don't think that any of this is actually damaged. It's just the masking. So I don't think anything's actually being damaged here. Let's scrape a little bit just to see where this all goes. Let's clean it up after a little bit of scraping. So this via here seems to go to the upper one, and this might be connecting to somewhere else, this pad here. But still, I don't think that anything is damaged here to a point where we need to repair anything. So let's get the power connected again, and let's see if that single 1K resistor already did bring our board back to life or not. So we currently have the 3000G connected. Let's turn on the power. And now we have more power consumption, 150 milliamps. That's a good sign. And let's have a look at these LEDs now. And power on. CPU. And CPU went off. That's a very good sign. Post codes are running on my tester. Let's see. The CPU is getting very hot. Let's see. Do we have a post screen? My hand might be burning up here. Do I have? Yes. Let's get this onto here. And we still have no LED indication. So I think we are RAM training right now. And we should be going over to VGA any second now. Let's see, let's put this down. The CPU is getting very hot, and I don't think that the board has booted yet because I didn't hear a beep. Let's see, I got a keyboard attached, but there seems to be no boot. Interesting, so it seems to be that we are stuck. Let's reset and see if that can help. So we're cycling with CPU LED with jumping current. Let's see, can we go to a RAM LED? And there's VGA and there's our boot. Okay, just a quick reboot. After that, just a quick reset. Got us a post screen, and now let's see a picture. Let's see a BIOS screen actually. And there it is. It starts telling us that the RAM is in the wrong slot here. That's good to know. Okay, let's turn this off. So with it turned off, let's now get RAM fully populated, because the previous owner said that he had problems with the RAM banks. So I actually want to see if we can get it to post in every single RAM bank. We might need to clean them out. So let's see now. I got everything connected here. Let's now turn this on and see if we can get 4 DIMMs of RAM to work on here and them to be recognized. So the picture that you see right now is still the image from before. Let's see if we can get a new fresh image that we can interact with. And we have CPU LED jumping, and the current is also jumping a lot up and down. So I think we're RAM training right now, which is a good sign. Let's hope that the RAM training actually succeeds. 3.2 amps, that looks very good. VGA LED, and we should get a post screen any second, and that's an actual post screen. That is very nice to see. and the board is restarting by itself a couple of more times because the BIOS has been reset because of the missing BIOS battery, and the board is booting into Windows, so the M.2 is also being recognized. That's a very good sign. As soon as we are in Windows, let's see if we have all the RAM banks active. So we should have a total of 20 gigs of RAM. So now the board booted into Windows, and as you can see, we have 20 gigs of RAM installed. We have Ethernet working. So we have 20 gigs of RAM, as you can see right here. We have working Ethernet, as you can see in the bottom right corner. And yeah, I'm pretty sure that the board is fixed now. And all there was physical damage. And I gotta say, physical damage like that happens so quickly. Like, I've had it before where I was taking out the GPU out of slot, and I knocked off components of the backside because it didn't have any backplate. And if when the owner had problems with the RAM, he probably took the board out and in, and maybe shuffled the GPU in and out, and or maybe had connectors down the bottom with like the front audio. And in those cases, it can happen so quickly to slip with the screwdriver, to knock against something and then rip off these components. Like, now you would expect, based on what he said, I would have expected something related to the RAM, but there was nothing related to the RAM. There was complete boot issue at the end with just one single 1K resistor missing. Like, you saw the area, there could have been multiple components missing, but all that was missing was a single 1K resistor that kept all of this board from booting up. And there wouldn't be any missing there would be a missing voltage, but no main voltage supply. Like, you wouldn't see that VDD, for example, is missing, but what it was for the multiplexer a signaling line. So I'm very happy and pleased for this repair. I gotta ask the customer if this had any water damage or anything like that. He might need to clean some of the areas up of this board, but with that, the board is fixed. We were pretty lucky on this one that it was just a single 1K ohm resistor missing. Hope you learned something, and hope to see you in the next video. Thank you very much, and goodbye.